All right, hello there. It's time to go to the next level. We're going to start getting into some serious algebra here, actually. I'm a little bit hot and sweaty. I've worked out just a few minutes ago, but I hope that doesn't bother you as we go through this. But yeah, let's talk about this. You already know how to do this. If there's an equation with one variable, I made a really simple one here just to talk so that there's no doubt about it. But you know how to solve an equation that's got one variable in it. The solution is the value that makes the equation true. 3 is the value of n that makes that a true statement. That's what solution means. Well, what happens if there's two variables? Well, let's look at this equation here. We got this equation's y is equal to 2x plus 3. What is the solution? Well, it totally depends. What y is depends completely on what x is. So, let's look at this. If we call that, because y depends on what x is, we call y the dependent variable. So if x equals 1, well, then we can plug in 1 for x, simplify, we get y is equal to 5. So 1, 5 is a solution. When x is 1, y is 5. That is a solution. But what if x is 3? Well, we can plug in 3 for x and get 6 plus 3 is 9. So the solution is 3, 9, where x is 3, y is 9. Well, what if x is negative 2? Well, we do the same thing. We plug in, we simplify, and that's when x is negative 2, y is negative 1. What if x is 0? Well, then 2 plus 0, or 2 times 0 is 0, plus 3 is 3. So 0, 3 is a solution. We can do this all day. We can plug in 1,000. We can plug in 0.01. We can plug in 7/9. You can plug in any number, and whatever x is will create some value for y. All of those are solutions to this equation. Every single one of those points. These are just 4 of infinitely many solutions. So the first type of question you will be doing out of this is just determining what are solutions for this equation when x is equal to negative 1, 0, 3. This is just for instance. It's not always going to be negative 1, 0, 3. These are just the ones that got plugged in right here. Well, when x is negative 1, you plug that in for x. Y is equal to negative 1 minus 3 when we plug that into this equation. And then what is y? Well, it's negative 4. That makes this solution, negative 1, negative 4. What if x is 0? Well, then that creates 0 minus 3, which is negative 3. So 0, negative 3 is a solution. And then what if, when it's 3, well, then you plug that in for x, you get 3 minus 3 is 0. So we end up, these are the 3 solutions for when x is negative 1, 0, and 3. This ought to feel pretty simple, but this is the first time we're talking about two variables within a single equation. And we would repeat in this case. So for this other equation, when x is negative 1, negative 2 times negative 1 plus 2, that ends up equaling 4. Negative 2 times negative 1, of course, is positive 2. When x is equal to 0, that's negative 2 times 0 is 0 plus 2 is 2. And when x is equal to 3, that's negative 2 times 3 is negative 6 plus 2 is negative 4. So these are the 3 solutions when x is negative 1, 0, and 3 for that equation. What about this equation? Y is equal to 0x plus 4. Well, that becomes 0 times negative 1 plus 4. That's 0 plus 4 is 4. What about when x is 0? Well, that becomes 0 plus 4 is 4. What about when x is 3? It becomes 0 plus 4 is 4. This didn't matter because we can actually simplify this equation. It's equal to y is equal to 4 is a way we could also say what this equation is. Because 0 times x is 0. So that it just goes away. All right. So let's go to the next thing here. We can graph these things. Now, this is what's special about these types of equations that we're looking at right now with two variables. If you graph these guys, if you graph each of the solutions from these 4 equations that we've had here, it makes a line. So it's called a linear, that's the adjective form of line, linear, L-I-N-E, line, A-R, linear equation. So these are the 4 solutions we had in the example above, 1, 5, 3, 9, negative 2, 1, 0, 3. If I plot 1, 3, x is 1, y is 5. If I plot 3, 9, that's going to end up here. If I plot negative 2, 1, that's going to be negative 2 to the left, down 1 is right there. 0, 3 stays on the x-axis and then goes up. I guess I actually stay on the y-axis, if you will. Doesn't move along the x-axis. And check this out. They make a line. That's supposed to happen. So we can draw that line through those points. And now here's the awesome thing. Those are 4 of the possible solutions, but every point on this line is a solution. So this line represents the solution for every one of these equations here. So I think here we go. Yeah, here's one of these points, negative 4, 5. If I plug that into my original equation, y is equal to 2 times x plus 3, check this out. Negative 5 times 2 times negative 4, that's negative 5 equals negative 8 plus 3. Yeah, it's a solution. It works. I chose that one instead of the x is equal to negative 17/19 because that would have been a pain, but it would have worked. Any point on these lines makes a solution. So a number 1, if you this is the number 1 from the example, negative 1, 4, negative 1, negative 4, negative 0, 3, 3, 0. They plot just there in that line. So this line is the solution. It represents the solution to every to that equation. For number 2, put those right here. That's negative 1, negative 4, 0, 3, negative 4, and 0, 2. Well, yeah, they make a line. And then this guy up here, negative 1, 4, 0, 4, 3, 4. This one is special. Remember how this could simplify and just be y equals 4, the x went away? Anytime you have a y equals something, it ends up being a horizontal line. You'll learn a lot more about why as life goes on with this, but that's a fact of it. So here's what I'd like for you to do. For 4, 5, 6, and 7, what you're going to do is come up with some values for x. I just made those up. Come up with values for x. I didn't mean to do that. You can use the ones I made. I can be a little bit creative. Use your own. I would recommend that on number 5, you might want to. I suggest these just for. Would you want to plug in negative 1 for x right there? Maybe not. Maybe not. Because 1/2 times negative 1, that's not as fun as some other numbers. So just give those a shot. Pause. I'm going to give this a few seconds. You can pause the video before you look at my answers. Okay, I'm going to now show you what your lines should look like. Notice that number 7 was weird. X is negative 7. Y is anything. Y kind of doesn't matter right here. So it ends up being a vertical line when it's an x equals line. Anyway, thought I'd throw that one at you. Hope this made some sense. Talk to you later. Bye.